Isn't that cool? We're actually live streaming. However, it's 30 seconds behind, so this whole conversation, it's like it hasn't even happened yet for all these people.
I'm gonna be waving in like 2 seconds.
Oh, look how excited I'm about to get. All right, so we are going to get started. For the people on the live stream, they'll hear this 30 seconds late, but we're going to get started in about 3 to 5 minutes. So again, anything that you need to do, you should get up and do it. You're not going to have much of a break once we get started. So, yay. Okay. All right. All right, all right, all right. Channeling my inner Matthew McConaughey. Okay, so we're going to get started. Like I said, we are live streaming this, which is really exciting. For those of you who are listening live stream, you are 30 seconds behind, but I'll be keeping an eye on any questions that you might have. For those of you in the crowd, if you have questions at the end, we will have a couple minutes for them, and I will be going around with a mic, and we will ask our speakers to repeat the question just so we can keep this going. Like I said, we have a really jam-packed schedule, so you don't get to hear me try to be really funny, like always. I know you're going to miss that. Live streaming, first time ever, thanks to Francesc. This is really what we've been trying to do for a while, so this is the guinea pig. So if this works, this could be a regular thing for the entire group. And we have 4, what's it called? Watch rooms, viewing parties. Ooh, muy fancy. We have 4 viewing parties. We have a viewing party in San Diego, the San Diego Gophers. Oh, that sounds like a baseball team, or if you're me, a football team, because I'm a football fan. Golang, Vancouver. Another Canadian startup, Edmonton. I always wanted to say it that way. And then Golang, Phoenix. So 4 groups, and you're all on the spot. So I expect some good questions to come out of this. Okay, let's go. Let's just get started. We're going to go over the state of Go with Francesc. So come on,
Thank you.
Francesc.
Wow. This is on. Better? Can you hear me at the back? Cool, okay. So yeah, hi, I'm Francesc. I'm a developer advocate for Google Cloud Platform, and I've been working with the Go team for, I don't know, quite a while. I want to say 4 years, but it might be more. And today I'm going to be talking about the state of Go. So I'm going to be talking about what we've been working on since the last time I gave this talk, which was 3 months ago. So it might seem like it's not that much, but actually there's a lot of things coming. So Go 1.7 is 9 months old. Go 1.7, it seems like it was a long time ago, but no, not really. Go 1.8, only 3 months. And on May 1st, we entered the release freeze, which means that we do not accept more features for Go 1.9, which means that this is actually a very good moment to go over all the things that we will have on Go 1.9. There's new things. There's more code that might come into the release, but there will be only bug fixes. So, and Go 1.9 will release sometime in August, hopefully early in August. If you try to run any of these things on the playground, it will not work because it's this from the future. That's the whole point. If you want to run a Go 1.8, it will not work either. You will need to install tip. So you need to compile from source and run it like that. If you do that, then it should work. Unless I have bugs, which is, something happens. So we're going to be talking is changes to the language. I'm going to be talking about 2 changes to the language. Then all the changes to the standard library, actually not all of them because there's too many. Changes to the runtime, then tooling, and finally we'll talk a little bit about community. So how many changes to the language we have? We have technically 2, but only 1 was accepted. The first one is something to solve a big problem that we've had in many projects. This is something that we've seen happening in Kubernetes. This is something that we've seen happening in Docker, for instance, and also internally at Google, which is how to do code-based refactoring, specifically how you move things from one package to another. There's a very good article by Russ Cox. That is actually the title is Code-Based Refactoring with Help from Go, so you can search it and read the whole thing. It is very interesting, and it basically says when you want to refactor something, what you do is you create the new thing, then you repair all the code that was using the old thing, and then you finally remove the old thing. Except that is actually not really the case. Most of the time is you create the new thing, then you wait for everyone to migrate to the new thing, and then finally you're able to remove the old one, right? And this is something that you can do in Go already, right? So let's imagine that we have the package HTTP, and for some weird reason, we decide to move all the status OK and everything to a different package called status. And if we want to move a constant, it is very easy to just say, well, that constant is the other constant, and that's it. Constants just have values, so comparing them will just work. So migrating from the previous API to the new one is actually trivial. So what if you want to do the same thing with functions? With functions is also pretty easy. You can define a new function that calls the previous one. And this will work except for comparison. The pointers will not be the same. And with variables, something really similar happens, right? But you can still call the function, which is what we do most of the time, and that will work. That will not break. So we can do it with constants. We can do it with functions. And with variables, it's pretty much the same. Actually, in the article, it explains a little bit more in detail what are the problems, because variables, they do have addresses too. So comparing them can be a little bit hard. But what about types? Let's say that I want to just rename a type, because I'm crazy like that. And I want to rename the type HTTP client to HTTP applicant. Why applicant? Because I found it on thesaurus.org or .com. It was the first synonym, so I went with that one. So imagine that we wanted to do this. It's an awful idea. Please do not send a proposal saying, hey, Frances said to do this. So if you go with the first one, you say type applicant is client. Now you have a type that you can convert from the previous one to the new one, right? But in the new one, you don't have any of the methods. You could add those. But even if you add them, the new code will be forced to write extra things to do the conversion. It is not exactly the same thing. They're similar types that could behave similarly, but it is not exactly the same, right? You could go the other way and make it even worse, in my opinion, which is do struct embedding. So you get all the methods, but now not even conversion will work. You cannot convert from applicant to client anymore. So this is a little bit of a problem, right? And this is something that we've seen in many places. So there's a new thing in Go 1.9, which is what we call a type alias, or an alias declaration. And an alias declaration is simply a new way of declaring a type. Rather than giving the structure, as we've done so far, type client is a struct or whatever, now what you say, just say type, the type name equals the other type. And this type is actually an alias, which means it is exactly the same type. Which means that if you are using it one or the other, you don't need to do conversions, because they're actually the same type. Also, you cannot add new methods if that type that you're aliasing is from a different package, because in Go, you cannot do that. I cannot add a method to the type int. It's not up to me to do that. The same way, you cannot do it by saying type my int alias int. No, because it's exactly the same type. And something that I find interesting is the fact that if you print the type of applicant here, you will not see applicant. You will actually see HTTP client. So it is actually the same type for basically all concerns. There's a couple cool things that you can do with APIs, which is the fact that it doesn't require any conversion. Means that all of a sudden, you can declare more types just for documentation issues. Before, if you declare a name type, all of a sudden, if people try to use it with another name type, there's a conflict, and you are forced to write a conversion. And with this, that need disappears. But the main reason for this is actually code refactoring. The second proposal is quaternions. And I don't know if any of you knows what quaternions are, but this proposal was sent on March 31st by Matthew Damsky. And he proposed adding a new type to Go called quaternions, which is something related to physics. And I really don't know what they are. But it's a crazy idea. And not only he sent this and everybody was like, ha, that's funny. No, he actually implemented it and sent a bunch of change lists with all the code to add this to Go. So if you really feel like Go should have quaternions, you can go find those CLs, patch them into your compiler, and use them. Have fun. OK, so that is actually the only change to the language, type aliases. That is the only change we have in Go 1.9. what about the standard library? In the standard library, there's actually a bunch of them, and I will go through the ones that I personally consider to be the coolest. You might disagree. So if you think that something else should be here, then write a blog post about it. But also, let me know, because this is personally what I find more interesting and the thing that impacts the most amount of people. So I did a poll on Twitter. And I asked, OK, so how many new packages in the standard library we're going to have? Are we adding 1? Are we adding 2? We're not adding any? Or we're removing 1? And 57% of 706 votes say that we're removing 1. So now we're removing 1. We need to decide which one. But no, we're not doing that, because that would break Go 1 backwards compatibility. So we will not do that. We're actually adding 1 package, only 1. And that package is math bits. And this package, what it allows you to do is low-level operations with bits. You can count the length of the binary encoding of a number. You can count how many ones they are in that encoding. You can reverse bits. You can reverse bytes. You can rotate to the left, not to the right. And also, you can count how many leading zeros or trailing zeros you have given a size. That X is because you will have the same thing. You have len 16, len 32, len 64 for every single one of the unsigned integers in Go. So here, for instance, I wrote this little program. And it tells you that 100 has 3 ones in binary. It's incredibly useful. It is actually very useful if you're doing things with bits, though. There's a new type in the sync package, a sync.map. It's a map designed to be used concurrently. The 0 value is valid, unlike maps in the Go programming language. In Go, if you just do var m is map without assigning any value, the map that you get is not usable. And with sync.map, it is usable, and you cannot copy it. You should be passing pointers instead. The important thing is this is something very useful, but it doesn't provide all the features that you might imagine. Meaning that you might still be able to write code that has data races even though you're using sync.map. I just did today. If you're getting something from the map, adding 1 and putting it back there, and you're doing from 2 different Go routines, that's still a data race. But you have some operations that are incredibly useful for this. I wrote some code, and basically what it does, starts 3 different Go routines and starts adding to their ID, keeps on counting how many numbers we've gone through, and then every second I print how many we got so far. And if you run it with the race detector, you will see that this works. And when I'm iterating over the maps over all the values on the map, you will see that the keys keep on changing. That is still random. Iterating over a map is random order. And other than that, give it a try. The important thing of running it with the database detector there is that if you wrote similar code with just maps, that would be a data race. That's the important step. There's one thing that might break some people's code, and I think it's important to know, which is if you have an HTML template, how many of you use HTML template? OK, not that many. So if you're using HTML template, there's a thing that allows you to escape strings. So you can do something, escape it with HTML to escape it in that way. And there's actually a security concern with this. This code here, what it's doing is executing a template that has a title, and that's it. That's a title. And it prints the string in the field bar, and it then escapes it. If you run this with Go 1.8.1, which is the playground, you will see something that you never want to see, which is HTML injection. So because of this reason, the HTML escaper, and actually all the default escapers, are now forbidden in the HTML templates. And when you do execute, if it finds one of those escapers, it will simply panic. So you might see this bug somewhere in the wild. It's important to know that this is actually for a very good reason. And then OS exec. This is actually a very simple change. And I also did a Twitter poll, and everybody was wrong again, which was interesting. But imagine that you have this program, basically env, but you give it the name of a variable, and it just prints the value, the value behind that environment variable. That is the program uses os.getEnv, so it gives you the first value in the standard in the environment that has that name. And then I'm calling that adding foo equals new bar to that, right? So I'm just adding one more environment variable, foo equals new bar. So if I call this, what value do you expect to print? Bar or new bar? It would make sense to print new bar, because what you're doing is I have all of this environment. I'm adding one new environment variable, right? So that is the new one, right? Like I'm adding here foo equals new bar. So of course it should be foo new bar. Well, if you run that from Go 1.8, that is exec min.go. Oh, run. It prints new bar because there's nothing, but if I do foo bar, it prints bar. It doesn't print the new variable that we added. It prints the one that was in the environment of the parent process. And this is not what you want to do. So we fixed it. And in Go 1.9, if you do the same thing, you will actually see new bar. What we've done is when you call command.run, actually when you call command.start, we remove all the duplicates of them in the environment variables. And we keep the last ones. So depending on what you're doing with commands, that may be something that could impact you. So it's important to know. Whoops. So yeah, that was the thing that everybody got wrong. But in this case, I feel like that's a good sign, because that is the behavior now. So I guess that's a good thing. OK, I'm going to talk about the runtime real quick. The runtime is around as fast as it was before. It is faster for some things, slower for some other things. But this is a benchmark that I ran myself on my laptop. So do not trust this at all. Official benchmarks will be coming later. So yeah, and I was watching YouTube at the same time. So who knows? But it's around the same, I'd say. There's new things coming for the garbage collector. There's new algorithms specifically for very large heaps. And large heaps around, it's more than 50 gigabytes. And I'd like to see, I don't know if you've seen, I've given this talk a bunch of times, and every single time there's that tweet with the garbage collector pauses before and now, and then before and now. I'd like to do that again soon, but I did not have that tweet yet, so we'll see. There's also another effort on the runtime, which is on dwarf, which is, I have no idea what dwarf stands for, but it's a joke anyway, so nobody cares. But dwarf is information that debuggers use to be able to understand a binary. And we're working on having more accurate information so debuggers like Delph can do a better job, and even GDB. Then we have a bunch of things in the tooling. The first one is if you write Allman-style braces, you'll have a slightly better error message now. Before, we just said unexpected semicolon or new line before brace, and now it says missing function body for main. And syntax error unexpected semicolon or new line before brace. You will also notice this one little thing, which is the errors now have column numbers. That is also pretty cool. Huh? Byte numbers, sorry. Not columns. Byte numbers. And why is this important? Because if you are using editors that signal where is the error, they will be able to point exactly where the problem is, rather than just highlight the whole line and then you need to parse the line to understand what the code is. So if you're a maintainer of any of the plugins for Go, VS Code, I think she is Ramya, or Vim Go, Fatih. Get started. I really want this. Then we have the Go compiler has been refactored. We've moved a bunch of code that was part of the Go compiler into packages that you will not see because they're under internal. And the Go compiler now does parsing concurrently, which means that the wall time that you will see when you're compiling code will be slower. Will be, not slower, will be lower. The time will be lower, so it will be faster. So this is good. This is a good thing. It will be faster in total time, but if you look at the CPU it actually spent, might be longer because we're using all the CPUs, which that's why Go exists after all. Go test. There's one thing that lots of people were complaining about. Go test ignores vendor. Yay! I know. So Go test now ignores dot slash ignores vendor. So if you have vendor directories there, you will not retest them every single time you want to test your code. So that is good. And another thing that we added is the -test.list flag. So when you're running tests, you can actually see all the tests that would be run without running them. And this can be pretty useful for the tooling if you're building tooling around it. Finally, GoDoc will have support for fields. So you can point to a field inside of a struct. So if I click here, I will go to the transport field in the HTTP client. That's it. It's actually useful for me, so I don't see why no one is reacting to this. This is amazing. And there's way more than that. I will not go through all the changes. We will have release notes at some point when the release is ready. But also, I'll be writing a blog post covering all of these things, and probably some more, because I will not have the time restrictions. So we're going to talk about the community. And the community, well, you just have to look around and on the live stream. Keeps on growing. We have, sorry? Oh, 250 people. Hello, people outside. They will see it in like 30 seconds, though. But so Go meetups, we have a bunch of Go meetups. I maintain this webpage, go-meetups.appspot.com. It's all automated, just grabs from the Meetup API. But keeps on growing. This is really good. I really, really like it. Out of all of these Go meetups, there's a bunch of them, now 20. And I did not update this slide, so it says 19. But we have Women Who Go. And Women Who Go, Sarah is right there, organizer of Women Who Go. It is a community for women that write Go code. And it is amazing. It keeps on growing. They're basically everywhere. And I think that soon there will be one in Africa, right? So Zimbabwe, which is amazing, because that's the only, there's nothing in Australia. Look at that. So homework. And one of the amazing things they organized is the Women Who Go GopherCon Scholarship. And they're helping between 40 and 50 people coming from diversity communities to go to GopherCon with the hotel, the trip, and the tickets and everything. So that's amazing. So round of applause for Women Who Go. And talking about GopherCon, we have more conferences coming. We have GopherCon Singapore. I will not be there. But GopherCon Denver, I will be there. Golang UK, I will be there. And DocGo, I will be there. Yay. So yeah, that's going to be fun year. And that's it for me. Thank you.
Any questions? I just asked online, too, so I'm going to be really kind of silly and walk around with my computer just in case in 30 seconds there's a question from the live stream. Okay.
Oh, but it's USB. Do you have?
So where does the documentation on a type alias go?
The documentation is actually in a couple places. There's a blog post about it, but specifically in the language specification. If you go to tip.golang.org, you will find the specification there. And there's all the changes already there available.
Oh, I meant like if I put in my code a type alias and I document there.
So it will be, if it's an exported alias, so if your alias starts with an uppercase letter, it will be part of your documentation.
Oh, cool. Awesome.
Yeah. In the package that exporting.
It's really weird to watch myself on live stream. Any other questions back here? I'm not looking behind me yet. The pressure is on you, all of you. No. Any other questions online? Going once, going twice.
There's behind you.
Oh, you had so much time while I was back there. Oh, I'm gonna get there. Wait, who was it?
It's a nit, I guess, but I'm just wondering why you can only rotate the bits one way and not the other.
I have literally no idea.
Okay.
Huh? Oh, good. Yeah, negative numbers, and they're unsigned. So yeah, that actually makes sense. Look at that. Yeah. That was rolled back, by the way. So yeah. I trust the source.
Sam online says pitch the developer experience working group. I don't know what that means, but I'm wondering if you do.
Yes, I should pitch it, indeed.
Well, then pitch it. Let's do it.
So there's a developer experience work group. We are some people from the Go team, from people from outside from outside Google too. We're working on making the whole experience of writing Go code easier. We are for now working on the beginner's experience, but we're actually going to be sending out a bunch of polls and doing UX studies to try to understand how we can make Go better from a developer experience point of view. I think that we will be doing something public at some point soon, but I will not say anything because I'm not completely sure.
All right, so this is regarding the Dash JSON flag to the testing package. Is there any word on that? That's been open for a while, and I'm just wondering if it's gone through many stages in terms of proposals and...
Anyone from the Go team? Jana? No. Do you happen to know the JSON flag for Go test? No. Okay. I can look at it later. Come talk to me later. Also, quick question. This is completely selfish and plug. This is awful. But how many of you know Just for Funk? OK. So Just for Funk is a YouTube video series that I do with me coding, and it's lots of fun. And I am late. It was supposed to come out today, but I was busy doing this. So for those that were waiting, sorry. And that's it.
Is that it? Are you sure? No more plugs?
More applause? Yeah.
Anything else? Oh, applause. All right, let's applause.
Thank you.
Thank you. Okay, so in 30 seconds, you'll find out online that we're no longer taking questions. And I'm going to introduce Matt to come up here and talk about event sourcing in Go. Round of applause for Matt, please.
Does this work? Is it on? All right, great. All right, I'm going to talk about event sourcing in Go. This is going to be my journey into it. My name is Matt Ho. I'm a technologist. I've been in the Valley for a long time, mostly with both small and large companies. If you guys are familiar with City Car Share, I built the technology for that back in the early 2000s. More recently, I started a company with some friends called Keaton that was acquired by Salesforce 10 years or so ago. So I've been working with both large and small companies. And really, like many of you, I've kind of had a journey that's led me to event sourcing, and I thought I'd share that with you guys. If you rewind the clock to the good old days, way back when, most application architectures looked like this. You had an app server, you had a database, life was good. It was really simple to understand. It was easy to scale up. When you wanted to figure out, does all this stuff need to belong in a transaction? Transaction boundaries were very easy to maintain. There were a lot of pros to it. But unfortunately, it wasn't all pros, as you guys know. Over time, because of various reasons, most monoliths that I've seen eventually turned into this, right? Very difficult to work with, calcified interfaces. Not to say that they're not good in some places, but it seems like as a community, we're moving farther and farther away from that. But that notion of a app server stuck to a database is a really powerful notion. It's very easy to understand. These days, I think we call it a bounded context, right? So rather than having all the applications stuck together, we realize that, okay, great. We can have a defined portion of the application stuck together. It can own its own database. and we'll call it a bounded context. And if we stick a lot of them together, we get this thing called microservices. Woohoo! Microservices for me made life a lot easier in that teams could move more independently from another and not have to worry about stepping on each other as much. But my experience was, as I fell in love with it, I also saw that there were some negative sides to it too. And the challenge is, now you've got all these services that need to find out about each other, that need to communicate with one another, and all of these has to be done in a real-time mode. So if one of these servers is not happy, then the whole system gets unhappy. Right? So if one of those goes down, it causes this back pressure that kind of spins right up the system. And what I noticed working in these microservice environments is, for as much as they promise faster productivity, my experience is they came with a lot of complexity. In fact, there was a whole who's who of things that I had to learn and sort of convey to the team so they could effectively work in the microservices world. So just a small list of these things, right? Now folks had to be aware of expand contract cycles because you've got services depending on each other. And how do these services find each other? What happens is if a service is down and I need to keep going, all of these have concepts that are probably worthy of talks in and of themselves. I'm not trying to do that talk here. This is really just sort of things that made me go, this is really a lot of stuff. And not only are there a lot of concepts, right, that when I have a bunch of services that are all required to process a request, now all of a sudden that 99th percentile, which I didn't care about in the monolith, becomes a real issue for me, right? There's a whole bunch of technologies now, app services like Console, etcd, Fabio, Kubernetes, that the team has to be at least moderately familiar with to be able to work in this new microservices world. What I've seen a lot of organizations do is even devote entire teams to building tooling around this microservice architecture to make it simpler for everyone else. And one of the challenges with the tooling is, because it's somewhat arcane the way that everyone's set up, where there's usually, and I put it in here, a lot of scripts that tie things together. Usually there's only a small number of people who actually understand this sort of thing. Just for a quick show of hands, how many people here are using microservice architectures? Okay, so I'm not trying to pick on you guys. It's just my own experiences, and I was just trying to see if there's another way to do this. And for those people that raised your hands, how many people can recognize some of the issues that I'm pointing out here? Okay, pretty much a fair number of them. In the end, I'm left feeling this way. I'm like, really? Do we have to do all this stuff? Is there another way? And so this was really an exploration to say, well, what can we do? I made up a wish list. This is kind of what I would like in whatever sort of thing gets created. And I hope, well, here's my wish list. I don't ever want to do another upgrade. Early in the Linux days when it first came out, I loved downloading the kernel. I loved building my own version. I loved the multi-stage GCC compilation. I was all down for that. These days, just give me a Docker image. I don't care to do that stuff. When it comes to troubleshooting, I'll happily troubleshoot the stuff I build. But I really don't want to troubleshoot your, etcd, Zookeeper. A, I'm not that good at it. And B, even if I was, I really don't want to do it. I'd rather focus on delivering business value rather than troubleshooting all these things. And the challenge is, even if they're containerized, at some point it will fail. And it's your responsibility for choosing the software to be able to fix the system. The third issue is I don't want to pay a fortune for it. I don't want to have to spin up a bazillion instances. I don't want to have to manage a bunch of servers. I don't want to have my finance person come to me and say, why is your AWS bill this? I often work with a lot of junior developers, and complex systems are very difficult to handle. So I want a system that's easy to explain to someone, where I can basically set them aside, for a few minutes and say, here's how it works, and they can be off to the races. And lastly, while I would love to have the problem of scaling, I don't want to have to think about it. I want somebody else to deal with this. So this is kind of my wish list going into this event sourcing world. Probably one of the big jumps for me to getting into this was a project that my team did last year. And we did this for T-Mobile as part of their T-Mobile Tuesdays. T-Mobile wanted to deliver stock to their customers as part of their T-Mobile Tuesdays program. The challenge was there was no system to do this, and we had about 4 months till the launch of the program. And so we had to build from scratch a stock distribution and accounting system in 4 months and have it robust enough that we'd be comfortable with the SEC, FINRA, as well as any sort of reputation that T-Mobile may have. And as you might expect, we forego the traditional microservices approach, and we went with an event-driven approach. The project launched on time. It was very smooth. T-Mobile himself was super excited. And my big takeaway from that is there really is something to this event-driven stuff. This system was built on top of DynamoDB. There was no SQL within the system. It was just a series of DynamoDB calls. And that really kind of opened my eyes of what you can do when you just give, when you surrender to AWS and just give in and do it its way. So, the heart of the talk, what is event sourcing? Let me start off and use a domain that we're probably all familiar with, e-commerce, and I'll just use this as an example. So the example we'll work with, and we'll call this the bounded context, is just a simple one. It's an order with an order item. I'm not even going to go through the order items. I'm just going to kind of show you this as a general concept. Most of you are probably familiar with something that looks kind of something like this. Right? If I were to go and design this in a traditional relational database microservice architecture, I'd probably end up with something like this. And I'm hyper-simplifying, so forgive me if I'm leaving out a bunch of stuff. In the database, there's probably a order ID someplace, and when the order is created, there's probably some state on it that says order created. And when I update it to say, hey, this order is approved, it's now ready to go to the next stage, what I'm going to do is I'm going to smash that state within the database and replace it with something. Kind of looks like this. Right? So now we've erased the old thing, we've got this new, right, updated the record, now it looks like that. And when the order gets shipped, we're going to do it again. And now it looks like that. This is probably familiar to everyone here. Well, if we were to do this in an event-sourced way, what event sourcing says is instead of having the database be the current state of the world, have the database just be the summation, all the deltas that went into creating that current state, and then you can replay the current state whenever you need to. As developers, how many people here use Git? Okay, and how many people knew that Git was an event source system? Okay, so with every version control system, what it is just a series of changes that you save for every one of your commits. And to get to that local, when you do a checkout or a clone or whatever, all it's doing is replaying those commits in the same order that they arrived to re-obtain your file system. Right, we're going to do the same thing then, but instead of with a file system, we're going to do it with this bounded context object. So we could create events that look like this. So our first event was order created, and you can pretend that there's plenty of other fields that are associated with the order created. I'm not going to bother to go into them. I'm just going to kind of put it up here to make this easier. And we can say the first event was order created, followed by order approved, followed by order shipped. And these three events together, when you kind of apply them in the right order, will give you the current state of the order, which is the order was shipped. How many people here have done or played around with functional programming? Okay, great. You're going to understand this then. So effectively, then, the current state of the application is nothing more than a left fold of previous behaviors. You just wrap them on each other, and huzzah, you get the stuff. I'm going to switch over and just kind of show you this in code now. Ah! Oh, up there. Oh, this is going to be weird. Okay. That is so weird. All right, great. Okay, so I have a little bit of Go code here, and again, I'm hyper simplifying just to illustrate the point. Where's the mouse? Okay, I'm hyper simplifying this just to illustrate the point. And so what I've done is I've created 3 structs: order created, order approved, order shipped. Again, you can add all the properties onto it you want. I'm just leaving them out for simplicity of the model. I've included a struct here which implements what I use for an event source, like the base, and I'll just go into it really quickly. It's too small. So the model itself just has 3 things. It has the ID, the version, and when this happened. So it's very similar to the diagram that we had. All right, so here are the objects. I'm now going to create this bounded context. I could have an array of orders, order items within this order, but again, for simplicity, I'm choosing not to. I'm just going to have the ID of the order, the current version number it's on, when it was created, when it was updated, and the current state of the state. So what does the left fold look like in the Go world? I'm just going to do a simple switch statement like this. So every time I receive an event, I'm going to switch on the type, and if it's an order created, I'm going to do some stuff. If it's an order approved, I'm going to do some stuff, order shipped. And you can make this as complicated as you like, but what I like is, for the simplicity case, I didn't have to think about ORMs or object mapping or anything like that. It's just straight Go code, which I feel is very much in the Go ethos. So it's pretty clear to see what's going on here. And now if I go down a little bit farther, I'll just kind of show you then the working example of this. So it actually all fits on the page. Woo! All right, so we're going to make up a fictitious order ID, 1, 2, 3, and we're going to have 3 events. The order was created, the order was approved, and the order was shipped. We'll instantiate an instance of the order, and then we'll just apply these 3 events. And at the end, we'll print this out, and we'll say the order was blah, blah, blah on this date. So let's go ahead and run this. Oh, God, that's small. All right, great. So you can see the order was shipped on that date and that time. All right, nothing really magical about this code. And what I like about that, going back to kind of my wish list, is I feel I could take someone, show them this, and they could kind of understand and follow along. And if they had to add a new event, they could add that without too much pain. All right, let's see if we can go back. So what have we done? We've basically just shown these 2 things. We created a series of events, and that order object is something I'll call an aggregate. Aggregate is a term from the domain-driven design context. And all I'm doing is just applying these events to the aggregate to receive current state. Well, how do I get the events? So to get the events, I can use, many of you are probably going to be familiar with this pattern, a command. So the command, when passed through a handler, generates the events. All right, so let's take a look at that then. Uh-oh. Okay, what you'll see is this thing is basically the same thing as I had last time. Order created, order approved, order shipped. And what I've introduced now are commands. And again, I'm leaving out all the details because they're just not important to the illustrating this. So I've created 2 commands, one called create order and one called approve order. And as you might expect, they're paired up with create order results in order created, approve order results in order approved. So here's what the logic looks like. And again, it fits all within this one view. On create order, I create a new instance of the order created event, and I return the list of events. So again, the command goes through a handler, and this is the handler, and it emits just 0 more events at the other end. When the order is approved, you can see here, I put a little bit of logic, and I said, you know what? In order for the order to be approved, the state has to be created. So I won't approve a already shipped order or an already approved order. So this command handler gives me the opportunity to kind of reject the command. Maybe it's a validation error, a business domain error. But like the event processor, it's just straight Go code. There's no magic. There's no funny business going on. It's very easy to understand. So putting it together, And here's the event handler from before. So now let's go take a look at the main. So in the main, we're going to create the order. So again, here is my order command. And I'm just going to tell the order object to apply this command. And what I get back is a series of events. And I'm going to apply those events in the order that they received, and just making sure that there was no errors on application. Then I'm going to approve the order. Again, I'm going to create the approve command, apply it, apply all the events that came out the other end, and then run it and see what I get. So when I run this, all right, we see that the order was approved, which is what we expect, and here is the time. Fantastic. My only problem with this is there's a lot of boilerplate code here to reapply the events. You know, there must be something better we can do to make this a little bit easier. And it turns out we can. Okay. So in this package that I have, this event source package, I have this notion of a dispatcher. And what the dispatcher does, in essence, is basically that code we just went through before, which is it executes the command, takes the resulting events that happen, and applies them to the aggregate, the order. And so what we've done is now that code that seemed boilerplate between these guys is gone away, and the dispatcher basically has the same interface as the order does. I could just say, dispatcher, create the order, dispatch, approve the order, and when I run this thing, just like before, I get order approved on this state. So fantastic. So far, we haven't done really any magic. All of it's just been straight Go code. Let me get back into this thing. All right. OK. So far, everything we've done has been local to my laptop. And it's all well and fine for it to be local to the laptop. But what does it look like when I want to try to put this thing into production? Where does this data go? What do I have to manage? So if we go back to that microservice issue, I don't want to have to manage stuff. I just want it to go someplace. Well, as you kind of saw from me going forward in the next slide, we had a lot of really good experience with DynamoDB. It was surprisingly robust. And so we figured we would try it with this as well. So DynamoDB, and just a quick show of hands, how many people here are familiar with it? Oh, almost everyone. So I won't bother explaining it then. Well, I'll do a quick explanation. DynamoDB is basically a NoSQL database provided by Amazon. Like all other Amazon products, it has this great capacity just to scale up as you turn the number up and you pay more, or scale down as you need less capacity. So what that means is we can take this, which is the order created, order approved, order shipped. So if this was a relational database, you can imagine we'd have an order ID column, a version column, and then the data column, which might be a blob of whatever data we have. And so if we have 3 events, we would have 3 rows in the database. You know, if you had 10 events, you'd have 10 rows, so on and so forth. Well, it turns out, because DynamoDB is a NoSQL database, you can play a little trick here. And the trick you can play is most of these events are going to be very small. If you have an event that's a couple hundred bytes, I would say that's pretty big. But most of these things are pretty small. It's right, a time, a date, a few things in there. A DynamoDB item, which is what they call a record, can store up to 400K of data, which is pretty big. So what happens instead of making each one of these a single DynamoDB item? What if we just kind of smash these together? And what if we took the DynamoDB item and we put a bunch of events in a single record? If you think of most objects like I'm really familiar with the fintech space, and so brokerage transactions. A typical transaction doesn't go through that many state changes, maybe a dozen, 2 dozen. So most of the time using DynamoDB, your entire event stream fits within a single DynamoDB record, which was a big plus as we were thinking about this. So as you end up with more and more events, you can imagine your DynamoDB table being shaped a little bit like this. So here's 4 rows. The first row, we'll call this page 0, has events 1 through 99. Page 1 has events 100 through 199, so on and so forth. So you can cram a metric ton of events into a very small number of DynamoDB records, which is a pretty neat thing. So what does it take to actually make this happen? All right, let's go to another code example. All right, here is, whoops, wrong. I want that slide. Where's the mouse? There we go. Okay, you guys are gonna hate this example after a while. All right, so this example, oh no. There we go. So this example is basically the same one I've been using. Okay, there's the command handler that we had before, the on. Everything is pretty much the same, but now I've done something different. I'm using this package that I put together for event sourcing. It's very simple. I'm not going to go into too much detail about it, just kind of talk about it at the high level. So it has the ability to use DynamoDB as a store. So here I'm saying in US West 2, there's a DynamoDB table called orders that I'm going to use as my store. And then I'm going to do a little bit of bookkeeping to basically set this thing up. So I'm going to create the repository where all my events are using this store, and then a serializer that knows how to serialize these three objects. So again, from the previous one, here's my dispatcher. And everything at this point is exactly the same, right? I'm creating the order, sending it to the dispatcher, checking it, approving it, sending it to the dispatcher. The only thing I've added here is this load command, which allows me to basically ask the repo, give me the current version of this thing, of this object with ID, the ID I pass in. And what it returns to me is an aggregate. An aggregate is basically, because I thought interface, I wanted something a little bit better than just open-close interface. So it's really just anything that accepts an on method. So I need to typecast that back into the original order object, which I do here. And then we'll print out the same thing. So before we do that, let us, let's figure out how to move this thing around. Huzzah. Okay, so here's the orders table in US West 2. I'll just do a quick refresh. Can I get rid of this? Okay, so I'll do a quick refresh and you'll see there's nothing up my sleeve. And now we'll go ahead and run that command. So huzzah, order approved on this time, and when I refresh this little sucker, here's the key. It's just some random gobbledygook, partition 0, and here's the base 64 encoded version of the event. In case you're wondering what's inside there, I'm just going to crack it open. And we'll paste it in here, which is a base 64 decoder. Decode it, and what you can see is it's just a JSON object. All right, just a very, very simple JSON object. Okay. So now we've got a place to put these events that's very scalable, but it's still kind of in this hermetically sealed world. We can create the events, we can stick them in there, we can retrieve them back, but how does it connect to the rest of my application? Where do those pieces go? It turns out DynamoDB has another fantastic service, and it's called DynamoDB Streams. This is connected to DynamoDB such that every time you make a insert, update, or delete to DynamoDB, an event gets created and thrown into this thing which you can consume and do something with. When I saw that, and this was for the previous project, I was feeling like this is fantastic. You know, so why is it so fantastic, and why was I just incredibly ecstatic? Well, let's see what we talked about. We got an application that saves its data to DynamoDB. DynamoDB then will dump its stuff out to streams, and it turns out streams can can connect to Lambda really simply. And here's where I think Go just shines so much. Because of Go's static binary, because of its low resource consumption, because of its very quick startup time, it's a fantastic candidate to use as Lambda functions. Through the Apex package, which I highly recommend, we've been using Go with Lambda for a while and just been hugely, I feel, successful with it. I've talked to other teams that have tried to use Python or Node, and oftentimes the challenges you hear is, how do I make sure that all of the dependencies I have locally get shipped up to the Lambda container and work there? I don't have to worry about that with Go. What I test locally is almost, well, it's exactly what runs remotely. So just that simplicity makes my life a lot easier. I can't imagine another environment to do this in. So what does it mean now that I have it in Lambda? Well, one use case, which I think is one of the most powerful use cases, is I can take that stream of events, reassemble them, and ship them into Firehose. Firehose is a AWS service that basically will take your stream of data and throw it someplace. The someplace in this case is S3. And what it does is it creates a directory structure, a little bit like this, where all the events go. And it's not going to look exactly like this, but just think of this as you feed events into it, and it throws it into this directory structure. They're kind of pseudo timestamps, so you can follow them by time. This is a wonderful thing. All your events since the beginning of time are in this directory. Has anyone here heard or used Kafka? Show of hands. OK. So Kafka is something that we explored using. Right? It's basically a place where you can get this ordered series of events that you can play back. From a pricing standpoint, relative to this, for this, I pay, what is it, 20.23 cents or 2.3 cents a gigabyte to do this, right, in S3, and it's highly redundant, it's super scalable, et cetera. When I do it in Kafka, I need to stand up a number of replicas. Each of the replicas are AWS instances. They're backed by EBS stores. I need a zookeeper. There's a lot of servers involved. Oh, no, by the way, even though Kafka is very reliable, I need engineers who understand how to use that. On the other hand, I could just throw it in this bucket. Why would I want to throw it in the bucket? If I just take that bucket and copy it to my local directory, I have all the events that the system has since the beginning of time. How hard is it to take a directory on your local file system and just run all the events to see if your system has changed? Being able to regression test your application is now way, way simpler. Being able to figure out if you've got a bug in the system. If I need to debug, I could take any object, and I could just see the series of events that got it to today. Testing is a lot easier. And because S3 itself also supports Lambda, I can make triggers so that if a new event stream object arrives and I want to do something like a count or send out an email, I can basically watch the new, I can watch Kinesis's or Firehose's delivery into S3, trigger off that to do something else, like a calculation, email, whatever have you. And then if I put CloudFront in front of the S3, I can do hyper-fast pulling. So if I want to replay a large number of events over and over again, I don't have to worry about really bogging down S3. So just to kind of wrap up, I think Firehose goes to a lot of places. If I need a big SQL store, it goes to Redshift. If I need to be able to query it, it goes to Elasticsearch. I can write more Lambda converters to basically convert the type of the data, so it's whatever shape I need for Elasticsearch or Redshift. Here's one of my favorites, though I use a lot, Lambda to SNS SQS. So if you take the event that arrives, let's say it's the order shipped. Oftentimes you want to have a side effect process that happens, like sending out an email. Well, if you think about traditionally how people do it, they like write to the database and then they send the email out. That's okay, but you have to realize sometimes your server is going to crash and that email is not going to go out. I would like a way to make sure the email goes out at least once. Here, because I can just take the event, throw it into an SNS queue, something can subscribe to that to send out the email. So it's a great place, like I say, to handle side effects. If you want to cross bounded context, it's a great way to send things across. It's great for visibility when things go wrong. So what we found with that T-Mobile system is when something breaks, the way a break looks is the SQS queue in front of something just starts building up. And it's really obvious what's broken because everything has a queue for it. And you can just use the built-in dashboard to figure out what's going on. I'll just throw out other things. Lambda is going to continue to grow. I have no doubt that there's more and more things we'll connect it to. And the key thing is having the event in the raw form is really kind of what enables this. So going back to my wish list and what kind of got me started here. I don't ever want to do another upgrade. I don't know if you'd build your entire system this way, but at least for this section of the system, I don't have any pieces that are my servers in here except my app server. Right? Let me just go back to the diagram. I got my app server, I got Lambda. Everything else is run by AWS. I don't have to troubleshoot Amazon. There are people that do troubleshooting are way better than me. I don't want to have to pay a fortune for it. Because I'm not really running that many instances anymore, when I looked at the bill for T-Mobile, the T-Mobile Tuesdays, I was just amazed. Lambda cost almost nothing. And on top of that, you get hundreds of thousands of free invocations. So it was just fantastic. I feel like I looked at my EC2 build and it was like this, and everything else was like this. And I was like, I want more of this, less of this. And also for the juniors, having a way to get them involved. Creating the events, modeling that as a more senior activity. But if once that event stream is set up, if you tell a more junior developer, hey, can you now send an email when can you also send an email when the order was created? Right? How would they do that? Well, there's a little event here that says, there's a queue that says order created. Listen to this queue, subscribe to it, send out an email. Right? All of a sudden, you've taken these tasks, and instead of having to understand the whole application infrastructure, how it deploys, getting Docker composed to run locally and all that stuff, now it's just read from this queue and write this thing. And the last one is the thing I get for free. Because it's based on Amazon and there's no servers of my own, if I want it to scale, I just pay more. I'm not going to have to re-architect my system. Well, if you get to like Facebook, Twitter scale, you're going to have to re-architect it, but whatever. I mean, I can only wish that I had that problem. All right, thank you.
You know what? I'm not going to put the pressure on you first this time, San Francisco, because we have a few questions online. Sure. We have more than a few questions online.
I didn't do it.
Okay. Let's start with Victor asks how to make sure events haven't been tampered with. What's the security model around S3 as an event store?
So the great thing about S3 is, like every AWS service, it's subject to the IAM policies and permissions. So one of the other things I like about this architecture is I didn't have to go build anything to create permissioning. Amazon has a great permissioning model, and for S3, it's very, very specific. You can even create an IAM policy that's down to the bucket prefix. So I think there's a lot of built-in stuff that Amazon has for it.
All right, Demetrios, I hope I didn't butcher that, Demetrios, asks why DynamoDB instead of Kinesis?
Sure. So it turns out it is partly Kinesis. DynamoDB uses Kinesis on the back end. So if you look at DynamoDB streams, it's really an early version of Kinesis. So why not Kinesis directly? It's really the read after write problem. So with DynamoDB, I can write my events and get a consistent read immediately. If I write it to Kinesis, I have to wait until it goes through the Kinesis machine before I can do my consistent read.
Okay. Victor follows up with, are you considering a dedicated event store database like Event Store or Eventuate?
So here's my personal take. One of the goals I had was I don't want to have to manage a thing. I don't want to have a person who knows a database. If I can get Amazon to do it, I think those databases are fantastic. There's a lot of great features. But what I'm looking for is I just really want to surrender to the cloud, if you will.
Yeah.
And just have Amazon do it. And event sourcing, at least how we're using it here, it's such a simple model that I don't know, I feel pretty good about this way.
Oh, okay. All right. 1, 2. That's it. But I'm going to start back there because I saw his hand first. I already saw 1, 2, and don't make me feel guilty by raising your hand in addition. Nope, I'm not looking.
Hi. So I was wondering, how does replay work, especially with large amounts of events, right? So you have multiple partitions,
right?
And you need to apply all of them.
That's right.
Every time.
Yep. So I'll just quote Greg Young on this. For the most part, like until you get to 1,000 events, don't worry about replay. Like, it'll be just fine. If you think about the number of objects that have 1,000 events, it's really, really small. And it's not in a space that I've had to work with. Oftentimes, most things that I've created, they have well under 100 different events. And like I was saying, because we're smashing so many events into a single DynamoDB record, it just turns into a single DynamoDB request.
You were my next one, right?
I guess kind of a follow-up, perhaps a naive question, but if the events are really separated by time, say they're 10 years apart, I won't be able to download all that S3 and run it back on my laptop, right?
No. So if you really have that much stuff, so if you're talking about a single event, you can absolutely just pull the single event right off of DynamoDB. If you're talking about going back and you have that much stuff, you can't hold it all, you can create a snapshot at some point, right? And the snapshot would be like what an accounting system does. End of day, here's the end of day close. You don't have to worry about the time beyond that.
And very last question, how do you handle sharding of commands to aggregates?
Why do I, can you have them clarify, why do I need to shard?
It says, can you ask how he handles sharding of commands to aggregates?
So I think I might understand what he's saying. I'm going to interpret that question as, how do you deal with multiple command handlers being invoked at the same time, potentially causing conflicting requests? One of the wonderful things about DynamoDB is when you do an insert, update, or delete, you can actually create conditions on the insertion of the request. And one of the conditions is you can do optimistic locking effectively. So if two people try to insert the same, event 3, 4, 5, DynamoDB will pick one that wins, the other one will get a failure and have to try again. Very similar to how a traditional database works.
All right, thank you so much, Matt.
Yep.
Okay, and Dimitrios, he thinks he's funny, and he kind of is funny. He says, just because you guys aren't on here, you guys and gals aren't on here to see, he says, side question, are all the Google Cloud guys in the room making faces at him for bringing up so many AWS things? I thought you'll get a kick out of that. So I know that we switched the agenda on you without informing you, because that's how I do things. And now we're going to have Rob Pike up here. But before, I'm going to shut my computer. I like to always ask this, and it feels kind of mean almost to ask this now, because we have so many people from all around the world watching on the live stream. In fact, I saw it get up to 301 watching live stream, which is pretty frickin' fantabulous. We've never seen that many people on, so it's really exciting. But who has traveled the farthest to come to GopherFest? Tell me, where? Oh, Roman. Cupertino. I already know someone that can beat you in the crowd. What about you? Montgomery Street. Definitely not very far. For those of you not in San Francisco, that is a joke, because it's very close. Roman, tell me. Tell the whole crowd. Say it again. I'm gonna really mess that up. Central Asia, Kyrgyz Republic. Kyrgyzstan. I knew that, but I wanted to say it the way you were saying it. Okay. Did he beat the person behind me, Matt? Peru. Oh, you'd have to Google Map that. There's my plug to see which one is farther. I can't do. Yes. No. I figured. I did. I figured. All right. Did I delay long enough? Did I? Is your mic on?
I don't know.
All right. Is it?
Is my mic on?
Sounds like it is, but it's a little quiet. You want to move up your mic?
Move it up where? It's on my neck. Where do you want it? My nose?
Yeah, closer to you. Yeah, it looks like it was covered by your shirt. Can you hear him in the back? No.
It's supposed to work.
This is the fun about a live event.
That's not gonna work. I don't know how to do this.
Try it on your t-shirt.
I was on my t-shirt.
Okay.
How's that? Is that better?
Seems better. Is it better?
Can you hear me at the back?
Back there? It's okay.
Okay.
All right, I'll try
Turn the
to.
volume up. Let's get some feedback. Okay.
Round of applause for Rob Pike, please.
Thank you. I'm going to give you a little overview of a system I've been working on for the last year or so. But in order to clarify something right up front, I want to understand it's not just me. There's several other people involved in the project, and I want to make that clear up front because people seem to attach everything to me sometimes, maybe because I'm the fool who gets up and talks about it. But that's okay. So let's start with a show of hands. How many people have downloaded something in order to upload it to another device? All right. How many people have downloaded something in order to share it with somebody by like mailing it to yourself or something like that? All right, that's good. How many people have downloaded, well, never mind, you get the idea. How many people here have bought digital media on, say, Google Play or iTunes or something like that? You're all wrong. None of you have. You've only rented it. If you lose the account, it's gone. So the point is, this stuff's kind of nutty, right? I mean, the picture's wrong here. Why is it that our data is so difficult to manage in the modern world? It seems like, in fact, we've gone backwards a bit. So a little bit of, let's say, personal history. There were computers before time sharing, but fortunately I didn't have to do them all that much. In the early time sharing days, which we'll call the 1970s, you logged onto a computer, all your people you worked with, your friends, maybe were on the same computer, and you could share stuff. You could say, here's the file name of the thing I'm working on, or something like that, and it was all very sort of community-like and kind of cool. Then in the 80s and 90s, the same kind of idea was applied across networks. So you could have distributed file systems, and you'd log on maybe in separate places, or separate offices, or even separate countries, who knows, across the internet, or with the ARPANET at the time. And it was the same kind of feeling, like you'd share stuff. Here's my thing I'm working on, you can have it. File systems like AFS and things like that. And that was pretty cool. And then the web came and sort of democratized it all, so that all your friends who weren't so computer savvy could suddenly access the net. But things started to go a little funny. And now in let's call it the 2010s, it's all in the cloud, and everything's out there and shareable, except you can't actually get it anymore. It's all hidden behind weird systems and strange things. And so, although there's no question that in many ways the modern world is much more interesting from an information standpoint than it was in the 70s, in particular, there's so many more people involved, and it's so much more fun, and there's way more cat videos. You've kind of lost your way a bit because you no longer have as much control over the data as you used to. Your data, your personal data, it's sort of owned by somebody else. Twitter has your Twitter feed. You don't. It's only available to you as long as you have your account, and they don't get mad at you. And just last week, I helped somebody fail to get their account back from a service provider I won't mention that I work for. To have the world be so broken and so democratic and large is wrong. It shouldn't be a requirement that your data is that removed from you in terms of service, while we're removing it from you in terms of the good things about removing it, like maintaining it for you in the cloud and stuff like that. So the world's gone a little bit funny, and I don't like it. And I've been thinking about it for a long time and roped some people in to help me think about it some more. And we created a system called Upspin, which is very, very, very young. So this is actually the first talk I've ever given about it. So don't expect a lot, but I want to explain what it is and why it's the way that it is. Okay, Upspin is a global namespace. It's literally designed to be a global space that we all can live in and put all of our things in a sense that we can name them with this space. It's not really a file system, and that's because global names are much, much easier than global files. The reason for that is that files can exist on someone else's terrain. I can still give a name for it that I can understand. They don't have to update their file stuff. So the naming protocols that we have allow you to sort of talk to anything that's already out there. We're not required to speak only to the things that we create and own ourselves. And that's very important to managing all the data. You want to be able to name the things that are in your Facebook feed or on iTunes or whatever, not just the things that you create yourself. It's all glued together with secure federated protocols, which I'll talk a little bit about, but not too much. And so think of it as being federated in the sense that email is, that everybody can individually have their own services and they all connect into this nice, happy place, much in the way that email is kind of a global namespace, right? We all know if you give me your email address, chances are I can send you mail. Upspin is kind of like that for other data. We have a very nice sharing model, very simple. I won't explain it in much detail, but I'll give you a flavor of it. So that I can share things individually. I don't have to make a file globally readable in order to share it with one person, which is a situation we often have today. Most importantly, perhaps, it's a layer above what's already there. We're not trying to replace anything. We're trying to connect what's already out there, be that social web services, file systems that exist already, your Tinder feed, who knows? Does Tinder have a feed? I don't know. And another detail of this, which is actually pretty important to the design, although it won't be very obvious from what I talk about today, is it's not really meant for corporations. We're not trying to solve corporate problems. They're working on their own problems, that's fine. This is something for personal use. Personal privacy, personal security, personal data, not a company. Maybe your family, maybe a group of friends, but we're not trying to save all of a company's data. And I need to explain a few things that Upspin really is not. It is not a file system, although it can act like one, and because of the way the names work, it sometimes feels like one. But again, it's a namespace, not a file space. It's not AWS or GCS. It's not a new cloud platform. It's not something like that. It's not Dropbox, although Dropbox is pretty cool. In fact, I'm presenting off Dropbox now. Dropbox has this problem, I think, which is everything gets copied everywhere. And since I'm a person, like I imagine some of you, who has a lot of machines, it's kind of crazy the way Dropbox copies everything everywhere. Convenient, but not practical when you're talking, say, petabytes. You can't have all of that copied everywhere. And Upspin would work at petabyte scale. It should. Not everybody has petabytes, but lots of people have terabytes. And I don't want terabytes copied everywhere either. It's probably most like Keybase, although it differs profoundly in the way the sharing works and in the intended audience. And as you'll see, also in the kind of data it can handle, but we'll get to that. And so, as I said before, the goal of Upspin is to take all these things that are already out there, but unify them into a single way to access them, share them, secure them, name them. So let's talk about these names. You all know the Unix file system space, I guess. It's equivalent to a lot of other systems you've seen out there. Upspin is a little bit like that, but there's no root at the base of the entire space. It's not a tree, it's a forest. Every user has what we call a private root, user root, and then the names of the things that are owned by that user lives underneath its own private root, which is named beginning with the username of the user. So an example makes it really easy to see. I might have an Upspin name, r@golang.org/stuff. r@golang.org is my username, and then the rest is a Unix-like file path that gets me to the Upspin object. Now, we're using email addresses syntactically, but semantically it's actually irrelevant that it's email address. Once you've registered with the system, the fact that it's an email address is irrelevant. It's just a piece of syntax. And there's a fair bit of discussion about maybe changing the way the usernames work. It's not important to the structure of the system at all. It just gives us an easy way to verify who you say you are when you grab a name and want to sign up. And then a terminology which will be important in a second, which is this user, which in this example is r@golang.org. That's called the owner of the tree, the Upspin tree beginning at that root. Okay? Then there's a sharing protocol that works above this. And unlike a lot of systems, the sharing is actually done by plain text files within the Upspin tree itself. So it's not metadata for the sharing. It's actually just a plain text file, which makes it both easy to work with, but also it's always really clear what's going on with sharing. Who can see this thing? The way it's done is there's a thing called an access file, which you can drop in any directory that defines who has the rights to do whatever in that directory. Read, write, open, close, whatever. Not close. Read, write, delete, list, things like that. There's 5 of them. And the text files look like this syntactically. There's one of the rights, like read or write or list, and then just a comma or even space separated list of Upspin names. And this last one on this example is the word friends. Friends here is a group, and it's a group of the group of people defined by the owner of the tree in which this access file lives. And a group file might look like this. It's just a list of other Upspin users, including groups if you want. So a group file might say these 2 people are in a group and we're going to work together. And so I can just use that simple name to provide access to that specific set of people securely. And then just in case the security people worried about this, how open this looks, only the owner can modify access in group files. So I can't give you access to the access files. Only I can do that. And that's a simple rule. But that's just protocol. That's not really security yet. The real security is that when Upspin stores data, which it can do, it can name data it doesn't store, but when it stores data, it's end-to-end encrypted by default. So no one ever sees the clear text except the person whose data it is, or the person who's explicitly being allowed access to it to share it. Okay? And it's encrypted at rest, which means that the storage servers in the cloud, which might be holding this data, never see the clear text. It's always encrypted. They can't read it. More importantly, the storage servers never even see your private keys. Public keys, sure, but not your private keys. So we have some belief that this is if you want it to be, you can use it as a genuinely private store where nobody can snoop around in your stuff. And I'll show you a couple of examples later of how that works. And the access control stuff I mentioned on the previous slide cooperates with the encryption in a way that works really nicely. If you have two people allowed to talk to a file or read a file, then the security protocols allow only those two users' keys to work on that file. And there's a technology for doing that, which I won't describe in detail, but security experts probably know what I'm talking about. I am not a security expert. So how is this put together? I'm not going to really show you much working stuff, although it does work, and I'll give you examples later of how it does work. But I want to show you a little bit about how it's put together, because it's a very Go-centric model. Of course, all the code is in Go. There's 3 servers. I'm going to show you the complete interface to the system that matters. There's a couple of other administrative details that you never see. There's one key server in the world, and it's called key.upspin.io, and all the systems know about it. And that is where user data is stored. And that it's one server or one group of servers cooperating, because the key to making all this work, so to speak, is that all the users live in the same namespace for users. If it splits into 2 separate groups, the whole system breaks down because we won't be able to share between the communities. So we want one community, they're all sharing a single key server. And that can be replicated and protected in other ways, but conceptually it's just one server. And then there's a storage server and a directory server. There can be many of those, and we expect there will be many of those. They might be at the scale of every user having their own storage and directory servers, or it might be a family or a group, or perhaps a company if a company wants to use it. And so there are lots of them. So think of, like, by my old analogy with Gmail, or email, pardon me, there may be email servers all over the place, but they can still talk to one another because they all understand the namespace at the top. Okay, so here's the complete interface to the key server. There's 2 methods. And of course, these are implemented across the wire as well as locally. It's the usual story. You can either look up a user, and you look up by username, like art@golang.org, and you get back a thing called the user structure, which contains the username, the public key of the user. I'm going to get public and private wrong once in this talk, I know. Public key of the user, and also what the network address of the directory and store servers for that user's information are, because that's important. Actually, you only really need the directory server. And then you can put back a user if you want to update the user record for that person. Of course, that's very strongly protected. Sort of typically, the only person who can do that is the owner, although there's situations in which you're administering a domain, you might be able to do it for multiple people. But conceptually, you can put back your own thing to change your keys, to migrate your service, whatever you want to do. That's trivial, right? Here's the much more difficult storage server, which has 2 methods. You can either get based on a reference, or you can put data back and get what the reference is. That's the complete interface to storage. Typically, but by no means exclusively, it's typically content addressing using hashes. And so when you do the put, you get back the hash. Then you look up the hash, you get back the data. Very, very simple. Okay, this one is much more complicated. It has 6 methods. This is a directory server. And you can see it's got simple stuff: lookup, put, glob, which is global, like matching star patterns. Delete, and then which access has a security thing. It lets you find out which access file is in force for this particular path. And then watch is a way to watch events happening if you want a tree and see what's updating on it. So it's pretty simple. There's only 6 methods. Between the 3 servers, there's literally 10 methods, which is pretty small. It's 4 fewer than Plan 9, so that's good. It's getting smaller. Notice there's no get. You don't ask the directory server to get your data. You do a lookup of the name. He gives you back the list of references for the name, and then you go to the storage server to get them. And that's just a design decision because it might be cheaper to not do it, so to have the directory server do the second order lookup for you. Also, the directory server and the store server will often be different machines, so there's no reason to go through 2 hops when you can do it in one. And the sort of reference primary implementation we have now for the store server, for the directory server, is a Merkle tree. That is to say, it's hashing the directory records and storing them in a storage server of its own. So it's using the store server technology to store the data for the directory server, but they're actually different machines. Okay, and then there's a client library. This is entirely a library now. The other things were services, which might be local, might be across the network, but the client is a totally local interface, and it gives you more traditional API to talk to these things, like file-like stuff, read and write and that kind of thing. Absolutely trivial, and a couple of other hooks for getting at Upspin-specific things. And using the client library, there's some special tools that have been written to play with Upspin things. The most important one is called UpspinFS, which is, of course, a file system that you can mount on Unix systems using Fuse that gives you a mount point into the entire Upspin namespace, globally, not just your own stuff. And so when you run UpspinFS, you give it a mount point, like I like /u, it's short. And then you can do things like cat/u/art-golang.org, some stuff, and see the contents of that file. But I can also cat/u/any other user in Upspin /something, and if I have permission, I can see that data as well. So that brings it all into the Unix space, which is really, of course, what we want most of the time, although there are other uses like phones, which for some reason don't have file systems. Don't ask me, I didn't invent them. Let me give a few examples to show you what I think this system is capable of. I should probably give you a demo, but the demos aren't as compelling as me just telling you. So they do work, though. At least some of them do. Let's think about media library. My Lightroom, what's the word for it? Catalog. My Lightroom catalog is stored in Upspin now. It's living in a Google Cloud instance, stored with store servers running there. There's a directory server there, and so on. And that means nothing big in terms of the way we used to think about computing. What it means for me personally, though, is I have exactly the same Lightroom catalog visible on all the computers I own. I don't need to copy it around, sync it up. I don't have to do that rsync nonsense when I move between machines and so on. It's a single library, but also it's in the network, so it's available anywhere, but it's also encrypted, so nobody else can see anything in there, and only I can see it. Unless I wake up tomorrow and I decide, this raw file on this day with this cool picture I want to share with somebody. I don't have to download and upload it. I can just drop an access file granting you permission and then mail you the name or send you the name of that object, and then you can use Upspin to go get it. I don't have to download it and mail it to you or some such, shall we call it, horseshit, right? It's just accessible. Another example, same thing with my iTunes library, is also in Upspin. Now it's a little different because it's a combination of stuff I've bought from Apple and stuff that I've ripped myself from CDs, and I don't want you to be able to read the stuff I've paid for. It's not right, you should pay for it yourself, but I do want Renee, my wife, to be able to do it, and so my iTunes library is readable by her and me both. So she can see our shared catalog that way using Upspin security. It's all still protected, and it all just works. In fact, as far as I can tell, it works great. I can't tell the difference between doing it this way and doing it locally. It's really good. As another example, so far all I've talked about feels like static files. That's never the interesting thing in these systems. Imagine you have something like a security camera, or your parent, you got a newborn, you want a nursery camera. You can put the camera into Upspin by running a little directory storage server nearby or on the camera, depending on how much control you have. And then you've got access to the data, whether it's a video stream or series of static frames, whatever it is, but it's encrypted. It's accessible only by the people in your family, which might be the name of an Upspin group you've created that has you, your wife, and your other kids or whatever. And it's now, I can't protect the camera itself. Other people can come in and do whatever they do with these crappy devices. But at least as far as the data that you're accessing it, it's secure, it's protected, and it's a streaming service. But it's in the same namespace. And if for some reason I want, I don't know, grandma to be able to see the nursery camera, I just change the access file, put grandma in there, and now from grandma's machine, so you can see the pictures. But again, nobody else can. It's protected. Okay? So that's a different example. I want you to understand this is not about naming files and securing files. It's about accessing information securely with nice, simple sharing. Okay? The example, this is the one I want. And I think it's not quite there yet for real use, but I want $home to be here. I don't want a disk on my computer to carry around with me. And let's face it, that's why you carry a laptop around. It's because it's got a disk in it, and that's got your stuff in it. So what? You know, why are you carrying your data around with you? It's crazy. Well, there are reasons. The modern world makes it necessary, but I think it shouldn't make it necessary, and we can fix it. So I want $home to be an upspin, and there are intimations that that's starting to be usable. Dave Prezzato, who's one of the guys who works on this, has one Git client. It's in his upspin, and so when he has two places he goes back and forth between, and when he logs on two places from two different computers, it's the same Git client, same state. Hangs up in the, leaves work, goes home, turns to his machine. Git is in exactly the same state as when he left it at work. He doesn't have to sync between them and all these other confusing things that he and I are too old to understand with Git. It just works. That's the state that I really want to get into. And I think we're months away from having that be my default state too. We'll see if that pulls off. There's also Chris Foster, right? He's actually here, has created a little service, which he'll have to tell you more about it maybe in a later GopherFest. But he's building on top of Upspan a more sort of fine-grained thing for people who don't want to deal with running more complicated stuff, so that you can, for instance, his example here, share your treasure map with your pirates or tax returns with your accountant or something like that at a very fine-grained level. And the Upspan API makes that very simple to do, even in a way that existing services can interact with. So what's the status? It's very, very early days. We've been working hard mostly on the protocols and the reference implementation, which is pretty much done. It's not that much code, but I think every line has been rewritten about 30 times. But it's settled down quite a bit now. The implementation works with GCP and AWS, thanks to Andrew, who just left. Came up over the weekend, I think. Unix works fine. Basically, any Unix will do. Windows, everything works except we don't have a file system plugin like Fuse yet. But I hope that might come, maybe through the open source world, because this is all open source, and we're really encouraging people who think that it's reasonable to have access to your own data the way you want it, would be willing to help us make this all work. Of course, every line of it is in Go. The actual vendor dependencies are really small too. It's pretty much self-contained with a few small exceptions. The web domain is, of course, upspin.io, and everything you need to know about it to get started is almost there. There's definitely some documentation improvement, but there's enough there to get started. And we'd really like some help for things like UpspinFS for Windows, but lots of other things too. Now, the most important thing, of course, is there's a mascot. You can't have a project without a mascot. And Renee designed another mascot for us, and this is Augie, and he's got an attitude. But he's basically skeptical about all those people trying to steal his data. That's what that's about. And that's it. Very high level, very simple. Thank you.
That was actually perfect, because online people were asking what is on your shirt on the feed. And I knew it was by Renee, but great to know that it's the new mascot that we can now get really excited about. There are a couple questions. Sorry if I don't get to them all. I'll start with this one because I think it's relevant. What is the actual federated wire protocol it uses? Something custom or something standardized?
I showed it to you. It's this.
Oh, did you show after?
That's it. That's the, sorry.
He showed it to you.
That protocol. That's the complete protocol.
Sam?
I mean, there's a couple of data types missing here, but those are the 10 methods that it's all built on.
Awesome. Do you think media service, this is from Harishran, do you think that the media service use case would encourage piracy of content as everything is encrypted now?
No, I've never encouraged people to break the law. That's up to them. No, I'm serious.
Don't break the law.
Don't break the law. But I believe that on the flip side, I don't want the law breaking my data either. So That's the way I think about it.
Oh yeah. All right, they're giving some really good questions, but I'm not going to get to all of them, and I will give the opportunity for a couple of you as well. Regardless, let's go with how is Go's concurrency features work in Upspin?
Well, there's the scaling, which is built right into the libraries, of course, which works really well. And probably the most explicitly, unusually Go-like thing is this watch API in the directory server includes a channel, actually 2 channels, which make it easy to write. It's tricky to implement. It's actually the hardest method of all these to implement. But it's pulling channels out of concurrency and works pretty well. And then making that work across the wire was a bit of fun, but we got it working. Mostly, Andrew did most of that work. So I think the real answer is the way it scales really nicely.
Okay. And Bryce Cubed, I'll get to the second part of your question because the first part is hard to read. Could you store sensitive information like tax records in Upspin?
Yes, absolutely. That's kind of what it's for.
So you can host your own storage
store very
server.
sensitive stuff and share it with one person, like your tax account. That's a perfect example. And in fact, the jungle that I showed you, this guy.
Oh, that's a good question too.
That's one of his examples.
Any thought of applying this to private chat, like in Keybase, at all?
I haven't thought about it specifically, but absolutely, it would work for that.
Yeah. So what transport does it use? Is there plans like HTTP?
We use gRPC for transport and had a lot of performance problems, especially on high latency networks. So we stubbed that out for now and are using a custom HTTP thing we wrote ourselves, which its protocol buffers in HTTP. It's about 100 lines of code. It's absolutely trivial. I suspect one day we'll throw that out and put gRPC back in once gRPC gets the performance back, which is work that's underway. But at the moment, it's a custom but extremely simple protocol.
And what are your thoughts on IPFS?
IPFS is another one of those global file systems, but it doesn't satisfy the combination of things that Upspin. There's a IPFS, Keybase, Dropbox, AFS. There's like 100 of these things, and they're all a little bit different. I think there are 2 fundamental things that make Upspin, well, maybe 3 that make it different. One is it's targeted at people rather than companies or organizations. Another one, which I think is really interesting and hasn't been explored yet by us, but we're very aware of it, is the directory server and the store server are not the same machine necessarily. They can be, but they don't have to be, which makes things possible. Something I'm going to do very soon is twin my directory server and storage servers. So there's a version on AWS and a version on GCP. So if one cloud provider goes down, I've still got access to all my data. That's actually very straightforward with the stuff we have. And then the sharing model is actually really unusual and I think really pretty. It's very, very simple to not only set up sharing, but also to look at a file and understand what rights are granted to whom, because it's just a plain text file in a very simple format with very simple rules. And the idea of ACLs being this sort of metadata on the side that most systems have, I find baffling. Now, Keybase has public and private as 2 subsets. Those are very, very easy to understand, but I want one in the middle. I want my family, and that's a specific difference, right? So I can talk about any other 2 systems, but the key point here is to understand we're not trying to displace any of those. Our goal is to go on top of them all like an umbrella that glues them all together. So I can have my Dropbox data, my Keybase data, my IPFS data, my local file systems, my iTunes data, my Lightroom data, all available in one thing where the same rules of access, privacy, and shareability apply. How's that?
I have 3 more questions that I'm going to take. I've already picked out who they are based on them raising their hands first, so you can put your hands down. Here's one.
Going back to the piracy thing, can Keyspin reverse look up who is sharing the files? Is there any fingerprint of me sharing the data to you and someone else can see that?
No, because this is part of the beauty of having the access files be plain text in the tree. They're protected by the same rules that they define themselves. So if an outsider tries to read your access file, it's denied. They can't see it. So they can't reverse engineer it unless they're specifically granted permission to come in and see it. It's part of the design. Yeah. It's clear. It's not opaque metadata on the side. I mean, they might be able to do some traffic also on the network. I don't know, but in principle, no. Yes.
How does Upspin integrate with other people who hold data, such as like a Twitter feed? Is it just it defers to that system for the data, or does it actually ingest
Yes.
that?
What would happen, I would love to see, I mean, we haven't done this, but I'd love to see it. What would happen was Twitter would take those trivial methods I showed you and provide that API to the data. They'd implement the data service, and then I'd have Upspin names for all the elements of the Twitter feeds. That's the goal. Right? Now, are they going to do it? I don't know, but I'd love them to.
Yeah, I just wanted to know who owns the key server?
Who owns the key server? Well, it
Yeah,
runs
like
in
who's
Google
paying for
Cloud. It's open source, and at the moment, it's the team that runs it. I guess you could say we own it. It's not a comfortable situation, and there's been some discussion on the issue tracker about what exactly that kind of thing means and how secure and safe it is and all that. We actually don't want to run a key server. We're just doing it because there isn't one available for us that suits our needs right now. As you can see, with such a trivial, 2 methods, get a user, put a user, just about any service could do. We just want to find one and let someone else take it over. And there's several candidates, they're just not quite ready yet. I wouldn't be surprised if next time we talk about the system, we're not running the key server anymore. It's some other party. All right?
Thank you so much, Rob.
Thank you.
I saw it get up to 351. Did you see it get higher, Francesc? No. Oh, I know. We lost a few, but it's okay. We've been over 100 for the last 45 minutes or so. Over 300 for the last 45 minutes or so. Yeah, that's what I'm actually going to ask everyone is how many people do they have at their viewing parties? Because in addition to that, we would have a lot more. All right. Waldemar, I'm not looking at you. Are you ready? Your slides look ready. Yes?
Hello? Hello?
Yeah, so it needs to be a little higher. And then toward you.
Like this?
Yeah.
Okay. Is this okay?
Let's just get real close, Waldemar.
Okay.
How do you feel about that?
Yeah.
Can you hear him?
Can
you hear him back there?
Hello, something.
Say something.
Can you hear
I'm
me?
giving up on you.
Louder?
They can hear you. Just speak as if you're speaking.
Okay.
No.
Is that okay?
Yeah, you can hear him. You can hear him. Round of applause for Waldemar, please.
So, how do you remove the bar? Okay, so this is a quick talk on how we went around adopting the context package into the NATS client. First, a big thanks to Francesc and his videos from Just for Funk, big fan. They were very helpful into getting introducing, really knowing how they work internally. So they were like big help. And so first, like a quick question is, how many of you are really familiar with NATS as a project? Okay, so I see some few hands. So there's going to be a short intro on what is it actually. So a little bit about myself. I'm Valdemar Quevedo. You can find me on Twitter, WallyQS. I'm a software developer at Apsera. I do development of the Apsera platform. And also I'm a maintainer of a couple of the clients from NATS, the Ruby implementation, which is the original one, and a couple of the Python ones. And I've been using NATS-based systems since around 2012, originally with Cloud Foundry. Also giving a talk on related how to the NATS client works at GopherCon this year. So I see you in Denver if you're attending. So about these talks again about first, like we'll cover a real quick what is the NATS project and what is the context package and when is it useful to you, and how we went around adopting the context package and adding support to the NATS client and why, and what can we do together with the context and the NATS library. So some short intro about the NATS project for context, right? It is a high-performance messaging system. It is open source under the MIT license. It was first originally written in Ruby 2010. Then it was rewritten in Go in 2012, and it got like super fast from that rewrite, and has been used in production for many years already at platforms like the Observa platform and Cloud Foundry, and it's gaining and increasing adoption recently. You can find it on GitHub under the nats-io organization, or the website nats.io. So the main characteristics from Nats is that it's fast, and it's very simple, and it's a resilient messaging server. There was a talk about the event sourcing and having like the message replay. So Nats does nothing of that. It has a very minimal feature set, and it's pure publish subscribe. And you could say it's at most once delivery in terms of like delivery guarantees that you get. It is TCP/IP based under a very basic plain text protocol, and where the payload inside of the protocol is it's opaque. So you could use JSON, protocol buffers, message pack. You're not coupled into using one of those. It could just be just raw bytes as well. But also, asterisk, if you are interested in like having these like messaging replay kind of capabilities, there's another project named Nats Streaming, which gives you an API for doing this at least once delivery guarantees. So what is Nats useful for? It's really useful for building control planes for microservices. And it gives you one-to-one and one-to-N types of communications. The request response is aimed to be like a low latency RPC. And you can also have distribution load balancing groups using distribution queues. And has a really good throughput. Locally, if you try to run the benchmarks, it at least will give you around 10 million messages per second. If you have a really small payloads, it will decrease as you bump the size. And by default, the maximum payload size is 1 megabyte. So some examples from the API, and start looking at some Go code. First, can everyone see this? Or should I? OK. So this is the Go client API from Nats. And here you see like you have you're showing interest into a hello subject, and whenever you receive a message, you will print this. And you're publishing a message on the hello subject. Here the payload is just a world. And notice that here we don't have any timeout, for example, right? So this API is it's all asynchronous. Many users from Nats, when I start using it, one of the first things they try is having this for loop where you're just publishing a lot of messages as fast as you can. And what this will cause in result is actually disconnecting you, because you're not able to consume the messages that you're publishing, right? But OK, so if you actually want to synchronously ensure that this message was published, you need to flush it from the buffer. Otherwise, all the API is asynchronous. The request response API for one-to-one communication, it is not asynchronous. So here you have you're subscribing to the help subject once again, and you're making a request on this on the help subject. Again, payload please. And you're going to give up waiting for a response on this subject after 2 seconds. This means that at this point of the code path, this is going to be blocking until it gets either an error or a response. OK? So this is where we start getting to the topic, which is the context package. One of the shortcomings of this blocking call is that there is no way to cancel the request. We need to wait for the result. And can this be improved somehow? So there have been some ideas already for a while in the Go community. There's the original this blog post from 2014 already. It's about pipelines and the doing cancellation via Dawn channels, and this is a very commonly adopted pattern at this point. And also, same year, we heard about the context interface and the context package. But it was until last year where it is already part of the of Go. So this is I think this helped a lot in for the adoption of this the context concurrency pattern. So you can see now, if you make a quick search in Google, you can see like a lot of open issues. Many people are trying to implement and adopt it. So this is one of the types, one of the simple queries I did, and it's almost 200 issues. So also internally, the Go is also adopting and adopting some of its internal methods so that they are context aware. Since Go 1.8, for example, we see that database SQL also has support for contexts and cancellation. So I guess the main tip here is that if it is a blocking call in a library that you provide, it will probably benefit from adding context.context support soon. So how do we exactly go around using context? This is the context toolkit. We see it's an interface that has a deadline, a Dawn channel to signal cancellations. You can only receive from, and you can the context can fail, which is going to yield the error. And there's also give you this map interface essentially where you can store request scope data, and it all starts with the cancellation, the cancel context, and from that you can start to have a deadline context or a timeout context, and also the request scope data with value. Short example of using it with the HTTP package. We're making a request to get some of the stats from a NAT server that is public out there. We have start from a parent context, then specify that after 500 milliseconds we're going to give up making the request, right? And we essentially wrap the request on this timeout context, then use the same client API from HTTP and wait for the reply. And we have two types of errors that we can get. One is the deadline exceeded error, which implements the net error interface. So if you do type assertion and try to check whether it timed out, it was a temporary error, that works. And there's also the canceled error, which is what you get if you cancel arbitrarily the context. So with this background, we will share how we went around adding support for context into NATS client. So first, I want to touch on what is essentially a NATS request. Basically, what happens under the hood is that you're creating this ephemeral subscription with this arbitrary identifier. Here is number 2. You're saying that you want to unsubscribe for any incoming requests after you get a single message. That's how you narrow down so that you only get a single message. Then you will broadcast this inbox on this help subject, so that anyone that is showing interest into helping in the help subject can reply back and write to the server that, okay, I can help with this ephemeral subscription, and here you get the payload size of okay, I can help. So there is writing, flushing, and reading from the sockets that is happening under the hood. Then that is essentially what you're waiting for when you're making a NATS request. So also internally in the Go client, calling NATS request on a subject, it is essentially also just syntactic sugar for doing basically this protocol. You created an ephemeral subscription, then you have a synchronous subscriber on this inbox. you say that you only want a single response. So you withdraw the subscription after this, and publish that you want some help on this subject and wait for the next message to be received. And here is where it is blocking, right? So this is the part that we'll have to change. So the first step that we did is to add context-aware APIs for this next message that all the subscriptions provide. And instead of having a timeout, we'll pass a context. Okay? And also, just in case, to avoid, since NATS has already been out there for a while, we don't want to break compatibility with previous versions. We added build tags so that it's only enabled for users of Go 1.7. So this is essentially what we will be changing. It's a very simplified version of how the next message method works. And here we have a channel over the subscription where we will be receiving the messages. We set a timer that will fire after it times out. But if you get the message before that, we'll just return the message. And this is what request is also using internally. So this is what we will change in this select. And but how about one first work in progress that we try to add support? It's for context is how about we just add it as part of the subscription type, the struct. And we could say that the subscription has a context in the struct. We just set the context, and instead of waiting for the timeout, we wait for the context to be done and get an error or the message. Okay, and so yeah, we're gonna try to this. But if you look at HTTP, for example, they actually use this this style for context support. And the request struct has a context type, has a context in its type, and you wrap the request with a context and send in and make the request. But if you follow the Go documentation, this style is not recommended. And instead, what is suggested is to, in your methods, you pass the context and plumb it through that way. So that's what we did. Instead of having this next message with a timeout, we expanded next message with context and receiving a context. So now we wait for a message to be received or for the context to be done and wrap up. And learning from the standard library, one thing that we hesitated a lot is in standard library, when you pass an ill context, it is called in panic. So for the first pass of this context support, we don't really have any panic explicit calls inside of the library. So we went around returning an invalid context type of error. Just because we don't want any explicit panic, but so any feedback there's welcome. But so now that we have a next message with context, and we can use it as a building block to have the request with context method, which is essentially replaces next message with context, next message with a timeout by next message with a context, and that's it. Now we have a context support into the NATS library. There was some refactoring that we had to do in order to get here, but in terms of the change set, it's not a lot. And this is how you use it now. Have a request with context using this cancellation, timeout-based cancellation of 2 seconds. And some of the features I really like from this, being able to use context, is the cancellation propagation. that you start from a parent context, and if you cancel the parent one, it will propagate throughout, and this really helps with the readability of the code, in my opinion. And so next, I just want to give some example usage of using these APIs that are context aware. An example could be you're making a probe request where instead of making a request and just giving up a certain time, we can make something fancier, which is like gather as many messages we can within 1 second and scatter the message. And similarly to how you have this read timeout, where after a certain point of time of not receiving data, you give up. In this case, we will hard timeout after 1 second, but we will also timeout and give up if we don't get any message within 200 milliseconds period. So this is an example of how to use it then. We start from the background context, and we set the timeout context to give up after 1 second, and we wrap the cancellation function done to on a time after func that will fire at 200 milliseconds. And each time that we receive a message, we will reset the timer. So we're also not using request with context, but next message with context, so that we can do this advanced usage. So we publish the request, announce that we want help on this subject, and each time that we receive a message, we will basically reset here. And let's say that if there's a subscriber that it starts getting more latency after a couple of requests, this means that we will not wait until 1 second for receiving everything, but after roughly 200, 300 milliseconds of after 300 milliseconds of receiving messages. So you get the data that is the most alive at this point. And just imagining the amount of code we'll have to do in order to get here without using the context package. It's I mean, it's the review time will have been a lot more, way longer. So here we have a pretty advanced usage, and we didn't add any selects, any go routines whatsoever. So I think it's a great thing. So for conclusions, if a call blocks in your library, it probably get use feedback from the community about how soon to adopt the context package. And again, some refactoring, it might be involved in order to get there, but again, it really helps for the ecosystem as a whole to catch them up here. And because again, context-based code, it composes very nicely, and it's very readable. Another thing that to highlight is it's very important to always call the cancellation function, because it's basically otherwise that way you prevent leaking some of the resources from using the context. And that's it for my talk. It's a short one.
Awesome. Yeah. Are there any questions? Going once? Going, yeah. I know. I'm just like, I'll just wait until you think of one. All right.
Since Nats is across different languages, not Go, the clients are not Go, will this be implementable fairly easily with some of the other, like Python or like, say, Java clients?
I'm not sure. I guess it depends on the language. I'm not sure for Python if there's something similar. And it's, I think, mostly a Go idiom that you get because of the concurrency patterns that you are enabled by the language. I think C# has something similar. That's what I heard. Yeah, I guess it depends on the runtime. Yeah.
Okay, and a question from online. What were your concerns? What concerns did you have before adopting context?
What?
What concerns did you have before adopting context? That's what it says.
I was adding an extra dependency was a hard sell. I mean, having to. Before it became part of the library. So, it's a minor concern, but I guess another one is that the adoption of the package, I think, will help a lot here. Once we see more people in the ecosystem having this context-aware APIs, I think we'll get. The benefits you get from adopting it will be a lot more. Yeah.
Awesome. Any other questions? Oh, all the way back. All right. I'll walk one more time. Oh, you're coming to meet me? Oh, man. It's awesome.
Thanks. One of the slides shown, like passing extra arguments with the context is not a good idea. Why is that?
Sorry, I couldn't.
Like one of the slides shown that passing extra arguments after the context is not a good idea. Like extra arguments, first argument is the context, and then you have shown like passing extra argument is not a good idea in any function. So why is that?
No, I guess it is.
Yeah, that one.
Sorry, I didn't.
Yeah, the next one is.
This one?
No. The one with the cross mark.
Is it about the HTTP one or? Okay. So this is about storing the context inside of a struct. So according to the Go documentation, this is not recommended. But it's just interesting that the request does have it as a workaround to enable it. But in general, yeah, I think that the idiom is to pass it as an argument over storing it in a struct.
All right. Thank you so much. Okay, so this was probably one of the most successful live streams that we've ever had. And I'm hoping that we are able to live stream next month as well. No pressure. And next month we'll be at Capital One. We'll be going over a bunch of things, and it's on the GoSF meetup page for San Francisco. gRPC is on there, Hyperglide, and APD, an arbitrary precision decimal package for Go. So there's a lot in that one too. Thank you so much. You also have to leave very soon because they're kicking us out because we can't be here very long. Thank you.